Hi everyone, Vladimir is here with our multi-platform game development tutorial part 18. I'm sorry for the delay before this current lesson, but this previous month has been pretty busy. I've been attending some conventions and going to some job interviews, so I didn't really have time or energy to make the tutorials, but hopefully now it's going to change, and today is going to be a pretty decent step forward. We're going to introduce new enemy types and new attack patterns to make the gameplay much more fascinating and interesting. So first things first, what we are going to do is, you see that I made 4 separate sprites. I've got them from our sprite sheet, which you have the link in my lesson. But there's a bat, ghost, skeleton and slime enemies. So the idea is that our enemies are actually going to attack in different patterns. For example, my plan is the following. The ghost attacks in horizontal lines, the bat attacks by diagonal lines, the slime attacks in a random pattern, and the skeleton kind of randomly chooses any one of those patterns and acts accordingly. So what we are going to do is, let me open my project. First things first, we're going to have multiple sprites for the enemies, so let's find a way how to organize it better. My idea is to add the new constants to our resources, which will indicate the enemy type. For example, let's go to the top. Public static final integer enemy vertical, which is our spider, is 0, spider. Public static final int enemy horizontal is 1, which is our ghost. Public, you get the idea, etc, etc, but there are going to be 5 variables, so you'd have to bear with me. Diagonal 2, this is for our bat. Enemy random, this is for our slime. And finally, which is universal enemy or ultimate enemy, for our skeleton. So this thing is done. One thing that we need to introduce is the type to our enemy. We're going to pass our type somewhere. So let's adjust the enemy constructor to accept an integer of type, and let's store this type variable somewhere. I'll add it before the enemy so I can copy paste it later, but yeah, the idea is that we assign the type to our enemy, and then later, according to the type, we are going to choose the attack pattern and the sprite of the enemy. Why am I using integers instead of enumerations? Because you cannot easily convert enumeration in Java from enum to integer, and we're going to generate lots of random stuff, so I think it made more sense. If you know the better solution, feel free to suggest it below in the comments. So yeah, that's how it's going to work. So first, the next thing what we need to do is, before we actually use our type variable, we need to find a way how to store the sprites. So we could duplicate the enemy sprite, but I don't think it's a good approach because we have a lot of stuff. So I think we need to make a hash map which will map our integer values of our types that we have introduced to the sprite values. This way we'll be able to look up the sprite only based by this type, which will greatly reduce the code. We will not need to write a lot of ifs to assign the correct sprite to our enemy. So enemy sprites, we have a hash map enemy sprites. You see where we initialized the enemy. Let's actually initialize the enemy sprites as the new hash map. It's empty, but let's start loading the sprites there. Enemy sprites, put enemy vertical, this is our spider. Actually, let's use game sprites, create sprite, spider, and forget this line. Next, actually feel free to duplicate this line, but let's just change the values accordingly. So the horizontal enemy is our ghost, right? The diagonal enemy is the bat, and the random enemy is the slime, and final, our universal enemy is the skeleton. So this should load the sprite correctly. The next thing, go to our enemy and actually replace this value where we set the enemy sprite. So instead of res enemy, we use enemy sprites, and we use get, and we fetch our sprite by type. Note that if you make bigger projects, it makes sense to make a separate getter function in resource class. That way you will be able to filter for errors. This way we're not safe when we look up by type. For example, if we introduce a new type and forget to add the sprite, well, there's going to be an error. But for the small scale project, it will do okay for now. Okay, so this one is working. We can try checking what's going on, but one thing that we need to adjust, one more last thing, is when we create our enemy in the game logic class. You see there's an error now because we've added a new parameter. So what we need to do is to generate the random number. You remember that our resources enemy universal is the last number, so we just pick the random number from 0 to 4, which should make sense. Then we run the game and we check what's going on. Let's see what's going on. And you see there's a slime. If we run it again, there should be a different random monster, which is pretty cool, I must admit. You see the skeleton, Mr. Skeleton, very spooky. But as you see, they are attacking in the same vertical pattern, which is a bit boring. So the next thing what we're going to do is to address the issue with the pattern. But actually no, you see I've noticed that our attacks just take too much time. The game is quite boring to play, and to save it somewhat, well, you know, I know it's a tutorial project, but I think essentially it's your task as a game developer to make the games fun. So that's a tough one. Let's go to our enemy. You see our update function. Where is it? Let's reduce the time between the attacks. You know, this value, base attack time. Let's change it to, for example, 1 second. But we don't want to enemy attack right away when the enemy entered, so let's add the delay, some kind of if time alive is greater than the warm-up time, create a constant field warm-up time and assign it to 2 seconds. So now in our update function, even if it is time to attack for the enemy and it's lower than 2 seconds, the enemy is not going to attack. Well, this is called the warm-up time for a reason. The player should not be attacked during it. So right, after that, I think it will make sense. Did we change the base attack? Yes, we've changed the base attack, we've added the warm-up time, and this should do for now. Right, you see we have the attack happening in the update function. It's okay because for the vertical lines, but now we are adding lots of attacks, so the code is risking to get bloated. And I think it's a good idea if we select the assignment code, where we choose the target tiles to a separate function. Let's create a function, private void function, and let's name it perform vertical line attack. And it has the same code that has been there. It's really the same identical code, and it just moved to the different function. So now let's create a similar function for the horizontal lines. And when I say similar, I literally mean that you should copy this vertical line attack function, paste it here. It's a bit of a spaghetti code, but I think it's easier to read this way in this case, because they're not entirely similar. We could, move the parameters to the function top and then act accordingly, but I don't think it will be good to do for now, because it will overcomplicate things. Right, so you see our checks. I've renamed the values from columns because it's about the rows now. Again, it's for readability. You can leave the variables as they are, but after you open the code in 6 months, do you want to understand what's going on? And you know, this is one of the purposes. So here we're comparing x, but we should be comparing y. If y is equal to one of the chosen rows, then we mark those tiles as ready for attack. Otherwise, we make them false because the condition fails. If you don't get it, try writing it on the paper, like a table when you assign values to row 1 and row 2, and then just go through the form manually and see what's going on. This really helps to understand stuff. So the two easiest functions are done. With the diagonal code, I think we should make a separate function to fill the row, to fill the diagonal row. So let's call it fill diagonal. We will pass the starting coordinate of the diagonal. It's always going to be from top to bottom. If it goes away from the field, if it crosses the borders of the field, we just move it to the left and start anew. So dx is the change. It's either 1 or -1, and we will need to go through the whole field. Logic. Let's go through every row of our game field, and we should calculate the coordinate for every row, and we do it diagonally, right? So we take our initial base coordinate, and then we add the current row multiplied by our movement dx. But if our new coordinate is actually greater than the rightmost coordinate, we should artificially reduce it. We move it to the left. Let's subtract maximum base x and 1, basically the length of the field. And something similar happens when our coordinate is too far on the left. Then we just add the length of the field, and it should be working that way. But after we're done with this, we need to also mark the tile as ready to be used for the attack. So what is left to do? We need to choose 2 rows which we want to fill diagonally, and we also need to mark the separate tiles as not ready to be attacked, as the safe tiles. So let me make a separate function, private void perform diagonal attack. Let's generate the coordinates for the first diagonal, and for the second diagonal they might cross. That's normal. Math utils random 1. So this value is going to be either 1 or -1, depending on our random. Yeah, it's okay. And the same one for dx2. We're going to have 2 different diagonals, 2 different values. In this case, it's okay. So similar to the previous functions where we choose the column, let's just copy stuff from perform vertical line attack, copy it, and we will adjust it. We mark all of the tiles as false. We choose the columns, mark all of the tiles as false, and then we actually fill the diagonal with the coordinates we have. It's a good idea to see what's going on. Let me just put the perform diagonal attack inside our update function and see how it goes. if we are successful. Alright. No, it doesn't look good. Or does it? No, I don't think it looks good. Or does it? Let me check again. So we mark all of the tiles as unused. That's alright. Then we fill the diagonals. I'm just thinking out loud. I'm just programming it here with you. Just figuring out the stuff. Let me see what's going on. Again. Alright. It misses the row 0 for some reason. You see there's nothing. There's usually nothing on the row 0. Which is not how we intended it to be. So why is there nothing on the row 0? Let me check. All right. Let's see. We're filling the field. Alright, you see, there it is, the condition. If I is lesser or equal than max base y, then we're in trouble. And it shouldn't be that way. You see, now everything is alright. The diagonals are somewhat working, which makes me happy. Right, so you can see the diagonal attacks are working. What about the horizontal attacks? Let's check them too. In our update function, just add perform horizontal line attack. Just to see what's going on, because this is important to test it while we are programming it. Otherwise, you might encounter the error, but then when you wrote a lot of code, it will be much harder to backtrace it, you know. So yeah, it looks like perform horizontal is great too. So the next thing left is the perform random attack and the ultimate attack, which will actually be a mix of all 4 attacks. So here's what we're going to do. Private void perform random attack. This one is similar in a way that it fills all of the tiles as false ones. And then let's just pick 10 different tiles. It's okay if they overlap, you know. And just mark them for attack. So 10 tiles shouldn't be too much. Right, so the first coordinate, we're just picking a random possible coordinate from the maximum x coordinates. Similar thing we're going to do with our y coordinate. And then we are going to do, we mark the new coordinates as ready for attack. Just to show you what's going on, let's go back to update function, replace the horizontal to our random attack, and you will see what's happening. Yeah, you see, totally random, absolutely random values. You cannot predict what's going on. The game is actually much higher because of this. Maybe I should need to reduce the warning time. Yeah, actually I should. We're going to do this, but in a bit. But yeah, you see the random tile attack is pretty random, as we intended. So one thing that we left is is to perform our ultimate attack, which the skeleton uses, which will be harder for the player to predict. perform ultimate attack. And the idea is that I generate the number from 0 to 4, like our functions that we have. Or rather from 0 to... yeah, make it 3. Otherwise... because 0, 1, 2, 3, 4. 4 numbers. 4 numbers, and then we just fill the data out. In case we have 1, we perform vertical attack, and then we break. The same thing with 1, perform horizontal attack, then we break. Perform diagonal attack, break. Oh no, we actually need 4 values. 5 values, because of the different attacks. Perform... no, we need 3. I'm sorry guys, I'm just a bit ill right now. And I'm just trying to write it. And not stutter. Default, perform random attack, and we break it. So yeah, this is how the ultimate attack is going to be. It's basically a mix of 4 different attacks, which is chosen randomly. If we can predict the attacks for the previous opponents, for this one, no such luck. The player will have to adapt and react quite quickly. So yes, what we are going to do now is actually we need to assign the attacks based on the enemy type. So in our update function of our enemy, let's just remove this perform random attack, which we used for debugging, and see what type our enemy is. So if our enemy is vertical attack type, we perform vertical attack and we break it. If our enemy is horizontal, we perform horizontal attack, then we break it. In case our enemy is diagonal attacking enemy, we perform diagonal attack and we break it. And in case our enemy is like random attacking guy, then we perform random attack and we break it. And finally, for the default, we perform our ultimate attack. This is for the skeleton, Mr. Spooky one. This should do okay, this should work, but one thing that I've noticed is that you do not see exclamation signs, which are used for the warning for the player. Player should see what's going on firsthand. So in our game screen, in our draw function, or render function, in our render function, let's move the rendering of our effect engine into a separate, much lower, after we draw enemy and the player, so that those effects are drawn above the player and enemy, above the player, so he can see what's going on. And the other thing that I was talking about is increasing the time of our warning effect. Let's up it to 0.75, up from 0.5. So as we open our game now, you can see that spider, okay, unlucky, which attacks us vertically. Let me die, that's okay. Okay, never mind, we're defeated. As you remember, the progress is reset after the player is defeated. So after I launch the game right now, I see the slime, which should be attacking randomly, which it does. So this one is definitely working. Let me see what's going on with the different ones. So we had a slime, we have a skeleton, which is going to attack us in random patterns. So far it's random. This one was diagonal, this was on diagonal too, and okay, horizontal, diagonal. So far I think it's actually working, and you see the vertical one. So yep, I'm sorry it took so long, and I'm really thankful for your patience, guys. I think this is it for today. I'm going to commit the changes in our GitHub repository and also make the transcript on our website if you're not the watching type. So yeah, thank you for watching. I'll see you next time. Vladimir is out. Bye.